Good morning, everybody. Aloha. Welcome back Thursday. I thought today was Monday. So weird having a holiday on a Wednesday. Anyway, hope you're doing well. You remember, you always want to do the warm up because the warm up will make the homework easier. And if you do the warm up and the homework, it makes the tests easier. And everybody likes it when the test is easy, right? All right, I'm not trying to trick you. Honest. Try it. Okay. Copy all this down. Some of these problems might even look familiar to you. Uh, we've done some like that. Uh, do your best and then come back and follow along and see how you did or get answers where you got stuck. Okay? We'll see you soon. Okay, here we go. Warm up. First, let's do those diamonds, the products and sum. Remember, the top is the product. That's the answer when you multiply two numbers or more. All right, and the bottom is the sum. That's the answer when you add two numbers or more, right? You can add a whole bunch of numbers. You're still getting a sum or a total. So 54 and 15, what works there? That's the 9 times 6 or 6 times 9. And 56 and 15, that's the 8 times 7, right? Same sum, different product. Okay, now I got 14 and 48. What's working there? That's a big 6 times 8. And the 42 and 13, most popular diamond ever. That one should be getting stuck in your brain, right? The 6 and 7. Now, 2 to the second power, that's one that we don't usually use when we first start teaching exponents. Why? Why would I not use 2 to the second power when I'm teaching you how to do exponents? Don't I want to start with an easy one? Ah, yeah, if you were able to know that the reason we don't like to do that one is because you can do it wrong and get it right. Remember, what's the most popular wrong answer for this? 10. Most popular wrong answer for here is 12. Most popular wrong answer, 8. That's when they think it's this times that. Well, guess what? When you do it wrong, you still get it right with 2 to the second power, right? It's supposed to be this times itself that many times that you end up with the same answer, 4. Now, if you get it wrong, then all of a sudden you think, oh, I know how to do these, and you're saying that's 6. It's not, huh? 3 times 3 is 9. 4 squared, remember, to the second power, you could just say squared. You sound like you're a very, very smart kid, right? 5 to the second power, 25. 6 squared, 36. 7 squared is 49. What's 8 squared? Okay, I am going through these pretty fast because I am thinking you know how to do these, and you've already done this. This is not 110, it's not 111, 121. Okay, and a dozen is a gross number. Start getting in your mind that 144 is also called a gross, just like 12 is called a dozen. 14 to the second power is 196. 15 to the second power is 225. 13 and 14, 169, 196. That helps me remember those. Okay. All right. 16 squared, 16 times 16. Everybody, 256. Good. All right. Remember to get the perimeter. You're getting the distance around. So how far does the ant walk if he goes all the way around? Well, here he goes 1 plus 1.8. That's only halfway around. Plus another 1 and another 1.8. If I had a multiple choice test and I said, what's the perimeter of this? One of the answers would be 1 plus 1.8. All right? Because a lot of people only add those two numbers, right? You're supposed to add them and go all the way around. Okay, so that's 2. That's 3.6. Remember, when you add, make sure you line up the decimal. If there is no decimal, you're putting it right there. Now, you got to trust me, I did that in my head. I know 18 plus 18 is 36, so the perimeter is 5.6. What are my units? Meters, right? Perimeter is just length. Its area is always square units. Now, how do I get the area? I multiply this times this. Well, 1 times anything is itself. How hard was that? Okay, so you could have, that's square meters, said, okay, pretend there's no decimal. 1 times 18 is 18, and then I go back one spot. But remember what 1 is, right? Don't make it too hard if you don't have to. All right, this one's a little tougher because we have some missing sides. We don't know what this is, we don't know what this is, and we don't know what this is. So we have to figure it out. Okay, where do I find that answer? In your brain. All right, this is where you make your observation and make your inference based on what you know and logic, right? Wait, that's science, isn't it? Yeah, there's a lot of overlap with science and math. Okay, so this is 15, and this is 5, and this is 5. From here to here is 10, and from here to here should be the same as that, right? So if that part's 10, and this whole thing's 15, that must be, that's another 5, huh? Now, if this is 6, what do you think this is opposite? Yeah, that's going to be a 6. All right, and if this is 4, what's this? All right, now I have all the numbers I need to find out what is the distance all the way around this thing, right? 6 and 5 is 11, plus 4 is 15, 20, 24, 29, 35, 50. Okay, I just want to double check. Check this out. If I made this dotted line here and dotted line here, that 5 goes up there, that 4 goes over here, that 5 goes up there, that 4 goes over here. So this is 10 tall, and this is 15. So 10 and 15 is 25. 25 doubled. 50. All right, now getting the area, I can do 10 times 15 and get 150. And subtract these 2 spots that got taken out. 4 times 5 is 20. 4 times 5 is 20. 20 is 40. Get 110. Let's double check it another way. What if I made this rectangle 6 times 15? That's 6 tens plus 6 fives. 6 tens is 60. 6 fives is 30. 60 and 30 is 90. And then here, 5 times 4 is 20. I got to add that. What do you get? 110. Okay, I'm going to assume we got it right. What are my units? Square inches, right? Inches squared. Okay, area is always squared. All right, this one got a few things to do. First, we have to find these missing numbers. Okay, it's like a puzzle. Then we got to get my total, and then we have to use the standard algorithm to prove it, and then estimate. A lot of things going on. Okay, now this is 40, and this is 800. 40 times what is 800? Well, 4 times 2 is 8. There's 1 0. There's another 0. So I'm going 20 on that. 2 times what is 6? 3. 3 times what is 300? 100. 40 times 2? 80. And 40 times 100? 4,000. So my total, I did number 1, now I'm doing number 2. 4,800, 380, almost done. 3 times 20, 60. All right. 14, 1, 11, 12, 1. 5,246. Man, that number looks familiar. Where did that number come from? Anybody know? Yeah, some of you know. All right, prove it with the standard algorithm. What is my standard algorithm? That's when I do 122 times 43. Uh, 6, 6, 3. Placeholder, because that's a 40, not a 4. 8, 8, 4. 6, 14, 12, 5,246. We proved it. Now I'm going to estimate just to make sure. That's about 100. And that's about 40. And 100 times 40 is 4,000. That's lower than it should be, right? Now, if you know your 12s, then you're saying 40 times 120, because 120 is just like a 12. All right, then you're saying 48 with 2 zeros. You're getting closer, right? But I know that both of these I rounded down. 122 down to 100, 43 down to 40. Okay, so I know my answer is going to be lower than the real one. Okay, but I wanted to make sure it was close. All right, everybody, rock your Thursday, right? Okay, talk to you soon.